Welcome back. Today we'll continue with what you call the kinematics. So the first topic we are going to cover today. Yesterday I taught, not yesterday, I think the day before yesterday, we did, I guess so, distance, displacement, speed, velocity, acceleration. So today we'll talk about uniform motion. Okay, so now we know what. Okay, before starting uniform motion, let me tell you something that we know v is equal to dx by dt. Okay, so dx is equal to v dt. Everybody understand this? Now, if we integrate both sides, dx v dt, this will result in, let's say, 0 to x, 0 to t. If this results to x equal to vt, then I say this is a uniform motion, because see, the v is constant all the time, constant all the time. So I can take out the v, and then dt is just x equal to vt. This is the thing. Okay, so main logic is that v should be constant. V can be speed or velocity. If you are taking distance or displacement, depends on you. If v is constant, that implies acceleration is 0. This is uniform motion. Acceleration is 0. Understand? So, and one thing is that the distance speed, forgot to tell you last day, distance speed is always greater than 0, and displacement, velocity, acceleration can be greater than 0, equal to 0, less than 0, any number it can be. Understand? Uniform motion, you understand? This is nothing but uniform motion, meaning that if this is the xt graph, means it covers equal distances in equal time. Understand? And if you draw the vt graph, it will be nothing but a straight line, because v is constant at every time. And if you draw the acceleration time graph, it will nothing be like this, because acceleration is 0 in all the cases. Understand? So we discuss the uniform motion. Now, as we know, motion, I told you earlier that motion can be divided into, we'll study in details, 1D, 2D, 3D. We will discuss 2D and 1D in great details, 3D light, not so much. So let's start today with the 1D motion. Okay, 1D motion. So 1D motion, there are some laws in 1D motion. Those are called the equations of motion. Equations of motion. Okay, so actually there are actually three of them. Okay, three of them. Let's discuss the first. So acceleration, you know, what do you know? Acceleration, dv by dt. So I can write dv is equal to acceleration dt, a dt. Okay, I forgot to tell you something, that equations of motion only hold when acceleration is constant. Remember this, acceleration is constant. So now if we integrate this both sides, dv equal to integration of a dt. Let's say this not 0, initial velocity v0 to v times 0 to t. This side will be nothing but v minus v0, and this will be, if we take a out common, because a is acceleration here and it is obviously constant, so this will be nothing but t, let us not do this, t to 0. Okay, I'll delete this and do this, t1 to t2, so t2 minus t1. So actually v is equal to v0 plus a t2 minus t1. This is my one formula. This is the first equation of motion. We'll apply it everywhere. You'll see it. Okay. Now let's discuss the second one. This is actually very important as well. Okay. Now we know what, that v is nothing but ds by dt, not ds, not a ds, dx by dt, dx by dt. So I can write dx is nothing but v dt. Now v, I learned now what it was, v0 plus a t2 minus t1 dt. Now integrate, let's go to the next page actually for this. So I'll integrate both sides. Dx is equal to v0t plus then it will be, I think, a t2 minus t1 dt. Understand? So let's do this to x0 to x, to x minus x0. Now whenever you start a body with whatever initial velocity, it will always have the initial velocity at any moment of time. Means, like, if a body starts moving with 5 meter per second, let's say after 5 seconds or 10 seconds, you will also always correspond with this data, that at the first time it always started with 5 meter per second. So this is constant v0t, let me write it better, plus half a t2 square minus t1 squared. This is, then x is equal to what, x0 plus v0t plus half a t2 square minus t1 squared. This is the second law, not law actually, the second equation of motion. Very important again. Let's go to the third one. The third one is something like this. So actually the third one, if you see, is that a is nothing but dv by dt, and we can write this at dv by x. This is a chain rule, I guess so, dt. So I can write what, a dx, this whole thing is nothing but v equal to v dv. Integrate both sides, then I'll get a common into x minus x0. Once again, x minus x0, this I'll do from x0 to x, and this will be v0 to v, and this side will be nothing but 1 by 2 into v square minus v0 square. So v square is nothing but v0 square plus 2a x minus x0. This is the third law. Very important for anything. Remember this 3 laws. Okay, not law actually, equations will be very much helpful in later times. So now let's do actually 2-3 problems. Now let me tell you this problem. Okay, there's a building. You drop this ball, okay, with initial velocity 50 meter per second, and let's say the height of the building is nothing but 40 meter, no, 50 meter. Let me make it 50 meter. Now tell me, what is the time taken to reach the ground, the velocity when it reaches the ground. Okay, now how will you do this? Now let's take this equation. This is actually our second equation, short form. let's not take the second equation, it will be of no use. Let's say this v square equal to u square plus 2as. With this we know the s, we know the a, we know the u, but we need the v, so we can actually solve this. So v is nothing but root over u square. What was the u square, I guess? So let's see, 50 meter square. So 2500 plus 2 into acceleration always downwards, the body is moving downwards, so into 10. Let me tell you something, always take the motion of this, the direction in the motion of the body. Like, since the body will be moving downwards, you always take downwards to be positive and upwards to be negative. Understand? But if I say a ball was thrown upwards, you always take upwards to be positive, downwards to be negative. It's better. So 2 into 10 into this is 50. Okay, take 50 common, so this place 50 plus 20 equal to nothing but 50 root 70. This is the answer. Okay, this is for the v. Now t, see, I know that v equal to u plus 80. This was my first equation. I used v0 t minus 2 seconds, but always take the first time as 0, so it becomes t. Understand? So v, we know how much, 50 root 70 equal to u is 50 plus 10 t. T is then nothing but 5 into root 70 minus 1 seconds. This is one easy sum we did. Let's try one more. Let's say this is one tower. These are all tower sums. The ball is thrown upwards with a velocity of 10 meters per second. Okay, then it reaches the ground at 4 seconds. Okay, now you have to tell the height of the tower. This is a famous question, man. So let's see. So can you see what is the displacement? If this is the tower, the ball goes from here first, then falls down like this. Have you ever thrown a ball? It goes like this. So the displacement is nothing but the height of the tower, because this part, these two vectors get cancelled. So now, since the motion of the body is upwards, we take upwards to be positive, downwards to be negative. Here negative, h should be negative because it's downwards. Understand? So we'll put minus, one second, minus h is equal to u is upwards, t plus half. Now see, g is nothing but always downwards, so it should be in the negative direction, minus g t squared. So h is nothing but sorry, u is 10, I gave, no, 10 into 4 minus 40 plus half into minus 10 into 16, 8 is to minus 40 plus, sorry, not plus, minus 80 equal to, then how much is, one second, I think somewhere I'm doing a mistake here. Yes, I brought the minus here, so it will be plus here. The answer is 40 meters. This tower is 40 meters high. So this is the part till much we'll do today. So meet you the next day. I think the next day we will start do some more problems, and then I think we will proceed. I'll not proceed, I'll do problems next day. 10 question jam the next day. Okay, bye, see you next day.